Hi, welcome to Best Value and Uncertainty. This is a refresher for Northview Middle School 2012-2013. I'm Mr. Glenn. So, what's best value? When we think about best value, it's essentially an average for all of your data, but it does not include any obvious outliers. And an outlier, of course, is a data point that just doesn't look like any of the rest of the data. It's clearly discrepant from them. If there aren't any outliers, then best value is done exactly the same as average. So let's get into it. Let's take a look at an example. What we have here is three teams of kids who collected data on how high corn plants grow under different light conditions. Team 1 grew corn plants in low light conditions, and you can see their data here in the 6 centimeter range. Team 2 grew theirs in half light conditions, and their values are anywhere between 8 and looks like 10 centimeters, with some 9s and 8.9s and things like that in the middle. And Team 3 grew their corn plants in full sunlight, and looks like their data is 22, 10, 24.8, 25.6, and 26.6 centimeters. One draws a little bit of concern right here is 10 centimeters. So let's look at how we would calculate best value for these data points. One of the things that I noticed right away is that 10 centimeter mark. I'm going to get my pen on here and let's do some drawing. 10 centimeters is not anywhere close to any of the rest of them. I'm going to call that an outlier, and I'm going to exclude it from my calculations for best value. So let's go over here to Team 1, take a look at what we would do. These are all fairly close. I'm going to include all of them. So I'm going to first add them all together. I'm going to take 6 plus 6.5 plus 6.4 plus 5.8 plus 6. If I added all those up, I would get a total of 30.7 centimeters, and then I want to divide that by my 5 data points, and that gives me a best value of 6.14 centimeters. Alright, for Team 2, I've got 8 centimeters. I'm going to add 10 centimeters, add 9.6, add 8.9, and add 9.2. I'm going to include all of them. They're all fairly close. If I add them all up, I'm going to get a total of 45.7. And again, I want to divide that by 5 because I included all of my data points, and that'll give me a best value of 9.14 centimeters. Okay, and over here on Team 3, keep in mind that I'm not going to include that 10 centimeters. It's an outlier. It's not like the rest of them. So I'm going to add 22 plus 24.8 plus 25.6 and plus 26.6 centimeters. If I add all of those up, I get a total of 99 centimeters. Divide that this time by 4 because I did not include one of my data points. And if I do that, I get a best value of 24.75 centimeters. Have that look in something that's a little bit neater. You'll see my best values show up down here. Again, I've added centimeters to give all of my data, all of my numbers a meaning. I add a label, so that gives me my 3 best values for my 3 teams. Okay, so now what do? So that brings us to uncertainty, and uncertainty is another way to talk about it is like a margin of error. So it tells me how close to my best value would I expect to find the true value. So let's go back to our data. To find uncertainty, come down here, I'll write down what I do. I'm going to take my highest value, and I'm going to subtract my lowest value, and I'm going to put that in parentheses because I want to find that number first before I do anything else. And then I take the answer to my highest minus my lowest, and I divide it by 2. So for Team 1, my highest value was 6.5 centimeters. My lowest value was 5.8. So I'm going to take 6.5 minus 5.8, and I'm going to come up with 0.7 centimeters. I then want to divide that by 2 to get an uncertainty of 0.35 centimeters. And then what I say is plus or minus. So basically what that tells me is that my true value is somewhere in take my best value, and it's either going to be minus 0.35 centimeters or plus 0.35 centimeters, somewhere in that range for those. For the uncertainty for team 2, my highest value was 10 centimeters, my lowest value was 8 centimeters. So if I subtract 8 from 10, I'm going to get an average of 2, or an answer of 2. And then I want to divide that by 2. 2 divided by 2 is 1 centimeter. So I would say my uncertainty is plus or minus 1.0 centimeters. So that tells me that above or below my best value by 1 centimeter, I would expect to find the true value. For team 3, there's a pitfall that a lot of people fall into, and they want to go back and re-include our outlier. But we like to say that once an outlier, always an outlier. So we don't ever include it. So that now means that my highest value is 26.6, and my lowest value is now 22. And if I subtract those two, I get 4.6, and I want to divide that by 2 to give me a uncertainty of plus or minus 2.3 centimeters. Now team 3, their corn plants grew the highest, but they had the best value, they had the highest best value, so the highest growth came from the full sunlight. But really, when you look at uncertainty, over here team 1, they may not have had the best growth, but they did have the best data because they have the lowest uncertainty. Low uncertainties are desirable. You want to collect data so that all of your data points are fairly close together, and that would mean that you have very, very accurate data. So the closer you can get to 0 for an uncertainty, the better your data looks. Let's try one for you. So here's a set of data. Go ahead and analyze this data. Take a look at it, calculate the best value and the uncertainty, taking into consideration if they may have any outliers. And you might want to push pause, get a sheet of paper, write down your best value, write down your uncertainty, come back, push play, and we'll see how you did. So I'm going to go ahead and move forward. And so what would I look for? Alright, so the first thing that I'm noticing is that Theo probably is not going to run a 100-meter dash as a kid in world record time. So I'm going to consider his time of 9.4 seconds to be an outlier. Maybe someone stopped their clock early, or they didn't get their stopwatch started in time when the gun went off, and so his time shouldn't count. Alright, so when I go to look at my best value, I'm going to come over here and use this part as my scratch paper, and I would take the 14.5 second time run by Mariah, and I'm going to add Ella's 15.8. I'm going to add Savannah's 13.9, and I'm going to add Jonah's 14.7. So I add all those together. 8 and 5 is 13, and 9 is 22, and 7 is 29. So put the 9, carry my 2. Alright, put my decimal point down here. And I've got 2 and 4 is 6, and 5 is 11. Add 3 is 14, and add 4 is 18. So I'm going to put that 8, and then I'm going to carry my 1. 1, 2, 3, 4, 5. So I have 58.9 as my total. To find my best value, again, I want to divide that by the number of data points I added together, and in this case it was 4 because I excluded Theo's time of 9.4. And I've got some division to do. So I've got a 1 here. So my 4 goes here, drop down to 1, bring down to 8, and 4 and 18, that would be 4, So I've got 16, that's a 2, bring down my 9, 7 times 4 is 28, drop my 1, bring down a 0, that's a 2, that's 8, drop a 2, bring down a 0, and 5. So my best value, I'm going to go ahead and round that to the hundredths place. So I have a best value of 14.73 seconds. Okay, just a regular average. Now again, uncertainty. Highest time minus lowest time, and then I want to divide that by 2. So my highest time was the 15.8 seconds run by Ella. My lowest time was the 13.9 seconds run by Savannah. So I want to take 15.8 minus 13.9. I have to make that a 4. 18 minus 9 is 9. And 4 minus 3 is 1. And 1 minus 1 is 0. So the difference between my highest and my lowest is 1.9 seconds. And then don't forget, 1.9, I want to divide that by 2. Uncertainty is highest minus lowest divided by 2. So, looks like I have a 9 over here. So that's 18, drop a 1, drop a 0, so 2 into 10 is... So I have an uncertainty of plus or minus 0.95 seconds. Best value and uncertainty. Best value is the average of all your data. You take into consideration and then eliminate outliers. Once an outlier, always an outlier. If you have one that's discrepant and far away from all the others, you don't ever include it. So that's what this is saying. You do not include it in any of your calculations. You don't turn around and put an outlier back into a calculation for uncertainty. The uncertainty is also thought of as a margin of error. It's a measure of how close all of your calculated data points are to each other. The lower the uncertainty, the better data that you've collected. Low uncertainties indicate good collection methods. You followed your procedure carefully each time, and therefore your results are more reliable. That covers best value and uncertainty. Good luck. If you need any additional help, come see one of us in the 8th grade science department, and we would be more than happy to walk you through some more of those. And this has been a presentation of Northview Middle School Science 2012-2013.